Good morning, everyone. March 30th, and it's been a while since Mr. Frichette's been since I've been back on the old camera and the old video lessons. So we're kind of getting back to it. Day 11. I hope everyone's safe and healthy and happy and hanging in there. I want to let you guys know too before we get started with today's just quick lesson. Make sure you guys are trying, chime in, talk to us. It doesn't have to be about math. It doesn't have to be, about the academics or anything like that. Just let us know everything's going okay. And, if you need somebody to talk to, chat with us, send us an email. Don't be afraid to reach out. So I just want to kind of say that and, hang in there. Everything will get back to normal soon enough. We just got to be patient. So without further ado, I'm going to talk a little bit about Mrs. McKeachik and Mrs. Dombrowski are going to start bringing some review back into the mix. I'm going to still start throwing some geometry stuff in there just so you guys can see it. But today I want to talk a little bit about solving equations with variables on both sides. Okay, we talked about this earlier in the year, but this is a review. It's a refresher. I'm going to go through a couple problems, and then I will post a link of just a quick practice, that you can take a look at and just, kind of mess around with when you want to keep your mind off different things. That would be a great time to do it. So let's take a look here. I got a couple problems. This is solving equations with variables on both sides. So as you can see, I have a little T-chart here. We're going to have the problem on one side, and then I'm going to talk to you about the steps. But I'm going to channel my Miss McKeachik, and I'm going to use some nice fancy colored Sharpies that my kids had and I found. So, that's a cool thing, I guess, about being home. I find things that I didn't know I had. All right, so let's start with this. We have 3x equals 2x plus 50. Okay, so we have variables on both sides. Remember, our first step is to make sure, right? It's to make sure that our variable, our x, is isolated or by itself on one side. It has to be by itself on one side, okay? So that's the one thing I need to do. So in this case, I don't have any terms on this side that I can combine, right? I can't combine 2x plus 50. Those are unlike terms, so I can't do anything with that. So I'm not going to be combining any like terms. Okay, that's usually the first thing you want to look for. Okay, can I combine like terms on one side? That's a question you always got to ask yourself. In this case, you do not. You do not have that. Okay, so our next step, like we said, we got to isolate the x. So we got to bring the 2x and the 3x together, right? And the only way to do that is what? Okay, so good. You have to use inverse operations to bring it together. And the only way to do that is to subtract the 2x on both sides, right? The 2x is canceled, right? Because 2 minus 2 is 0, or 2x minus 2x is 0. So these are just going to cross off. I like to put a line underneath. And then 3 minus 2x is just x. Yes, there's a coefficient of 1 in front, but you know what? It's not a big deal. Okay, so we don't need to know. X is the same thing as 1x. And yes, can I draw my railroad tracks or my wall? Absolutely. So that's step 2. Okay, and I'm going to keep my purple pen here, but that's step 2. Step 2 is inverse operations. Right? You need to say to yourself inverse operations, but you need to, what we call, you want to get your variable term alone. Right? So we got that. That's question 1. So now we just need to rewrite what we have. Our 2x minus 2x is gone. And then this is just simple in the fact that it's x equals 50, right? So this was, you had 2 steps to follow with this, right? Did I need to combine any like terms on one side? No, I didn't. But I needed to use inverse operations to get my variable alone or isolated. So your final answer is x equals 50. Now, let's take this a little bit further. Can we check our answer? Absolutely, we can check our answer. And the only way we can check our answer is the first step we need to do is we need to rewrite our problem, right? So we are going to rewrite. We're going to go 3x equals 2x plus 50, right? And I'm going to put that for our first step. When we're checking, right? When we're checking, first thing you got to do is you got to rewrite original problem. Which I did. Step 2, do we know what x is? Absolutely. I know you guys are all saying it's 50. So we need to substitute our value for x. For example, in our situation, x equals 50. So wherever we see an x in this original equation right here, or our original equation, we got to put a 50 in. So 3 times 50 equals 2 times 50 plus 50. Okay? Remember, when you have a coefficient next to a variable, that always means you have multiplication. Okay? So that's something that plays into the game as well. So going through, now we're going to bring out our calculator, right? We can always do 3 times. You can do that in your head, obviously, but I always like to use the calculator to check. So 3 times 50 equals 150, right? 2 times 50 is 100 plus 50, right? And it looks like everything's going to check out. Does 150 equal 150? Yes, it does. And the other thing you need to tell yourself, once you substitute everything in, you got to say to yourself, you got to follow order of operations. And you guys know that as PEMDAS, right? And I'll put PEMDAS in there so you know. And PEMDAS is parentheses, exponents, so like x squared. Multiplication is multiplication. We also know multiplication as a dot or parentheses. Division, right? Division can also look like this, x over 2. Same difference. Addition, we know what addition looks like, and we know what subtraction looks like. So with this one, we jumped right down to multiplication. Okay, because we did not have parentheses and we didn't have exponents. So I was right down here in multiplication. That's where we started with this one. So as you can see, we're using our steps and we're thinking through the problem as we go. Okay, one more quick problem, and then I will post this to my YouTube channel, and then I will also post it to Google Classroom. Okay, so let's go up here. We're going to look at some of these problems, and you can see. So this one's a little bit more difficult, a little more in depth. So, what is the first thing we need to do? Do we have like terms on one side? So we're going to say that. Can we combine like terms? Let's see. On the same side? And it looks like we can't. 20 plus 2x is not a like term, and x plus 56 is not a like term. So this is done. Question 2, or step 2. Now, we know from talking above, we have to isolate or get our variable, right, and our constant terms together. They need to come together. We need to reunite them. So the only way we can do that is inverse operations. like I said before, we have to get our variable term alone. In this situation, it is x. It could be y, it could be z, it could be w. Doesn't matter. So that's what we're going to do here. I'll bring my red pen over here on this side. So what I want to do is I want to keep things positive. So I'm going to subtract the x on both sides. I'm also going to draw my wall, right? So we can split it between a left and a right side. So x minus x, or 1x minus 1x is 0, right? That's why they cross off. So the only thing I have left over here is a 56. On this side, I have the 20, right? And what's 2x minus 1x? And that's just plus x, okay? So we still have our equal sign here, right? So now we have 20x, or 20 plus x. Those are not like terms. I cannot bring those together, okay? So you got 20 plus x equals 56. The x needs to remain alone. So, once again, we are still on step 2. We need to do inverse operations, okay? We need to get the constant term over with the 56 because those are like terms. So the only way to do that is we have an addition here. It's a positive 20. So the only way to get rid of it is to subtract it. And whatever you do on one side, you got to do on the other. Remember that balance we talked about? Ms. McKeachik and Mrs. Dombrowski talked about having that balance when you're solving equations. That's exactly what this is. We're creating that balance. So 20 minus 20 is 0, so those are gone. And this is going to work out great, right? So what's 56 minus 20? That's great if you want to put it in your calculator. I am not. That's going to be 6, right? 36. X equals 36. Okay, so obviously they can get a little harder as you go through, but this is a two-step, in terms of what our steps are to solve, you're going through, right? So the final thing I want to show you again, let's do another check. This time I'll do it in orange, right? So what's the first thing we need to do? We need to rewrite our original problem. That's the step. In orange, it's not doing it. So here's our check. We're going to rewrite our original equation. Right? Now, we know what x is. Now we need to substitute in what our x value is wherever we see an x. So we have 20 plus 2 times 36 equals 36 plus 56, right? Now we got to think PEMDAS, right? Parentheses, exponents, multiplication, division, addition, subtraction. Now, we do not have parentheses. These parentheses represent multiplication, or that operation. So don't confuse that. We don't have exponents, but we do have multiplication. So we have to do our multiplication before we can add. Otherwise, this is going to go, we're not going to get the correct check. So we have 2 times 36, which is 72, plus 20. Like I said, use your calculator. It's okay. 36 plus 56. I'll throw in a calculator action right here. Bring it down. 36 plus 56, we'll do a mix match, that's 92. And when we do that, 72 plus 20 is 92. 92 equals 92. So we are correct. This checks out. Okay, so this is solving equations with variables on both sides. I'll post some practice on there. Here's another quick look at it. Go through, pause me, stop me, go through. Like I said before, guys, have some fun with it. Just practice when you have some time. Should also try to get outside. Do some things that you really enjoy as well. I mean, like I said, it's a tough time. Stay healthy, stay safe. I hope to see everybody very soon.